Okay, this is the fourth one. This is work solutions for graphing and trial and improvement. The intention is just to check through and make sure we know what's going on with these. Probably, I don't expect us to use this. I made a special note down here to remind you that with trial and improvement, you do need to show that if you know an answer is somewhere between 5 and 6, you should find where that number is at the next decimal place, between 5.2 and 5.3. Once you know that bit, if that's all you want is the one decimal place, you go to 5.25 to find which one of these two is correct. If you don't show these two numbers either side, that one's high and one's low, you're going to lose marks. If you don't do this split to choose which one is correct, you're going to lose a mark. Personally, I wouldn't say it must be the 5 on the end. Although often in mark scheme they'll let you a little bit of a drift, but that doesn't clearly show that you understood which one is which. The 0.5, the 5 in that decimal place will tell you which one of these two to choose. It will knock out the wrong one. If this is too high, it will knock out, then it will knock out the 5.3. If it's too low, it will take the place of the 5.2, and therefore you know it's 5.3. Make sure you understand that about trial and improvement. So question number 1, I know the graphs are a little bit small, but if you make it too big, then you can't see on the screen. So this is a basic conversion graph. She wants to change £200 into rand. So you start, where is it say on the graph where £200 is? Here. Read up to the graph and then read across how many rand is it. If you read across, it's 2,600 rand. If you're within about 50, it'd be okay. So between 2,550 and 2,650, you'll probably be given the mark. Simon has £100 and 3,700 rand. Goes to the shop where he can spend both pounds and rand. He wants to buy a computer, a watch, and a camera, all in pounds. Which of these items can he afford to buy? Must show clearly how you can get your answer. Well, there is a logical thing to do with this one, which is make sure your units are the same. So we've got a unit in pounds, and we've got a unit in rand. So my first step would be to turn that rand into pounds. So go to the graph on 3,700, and there isn't one, which gives us a problem. Now this is where understanding proportional graphs is useful. Because we can't use direct reading, what we need to find is we can convert 3,000 and we can convert 700 separately. It's up to you which numbers you use, but I'm going to split it by 3,000 rand and 700 rand. And I'm going to change those into pounds using the table. So 3,000 rand, if I read across and down, 2 squares before this one. So 2 squares looks like that's going to be 10 squares is 40, so 2 squares is 8. So that looks like that's going to be 238 and 232 pounds, sorry, because this is 240, 2 squares back, 4 per square. So if we look on this, somewhere away from where 700 is going to come in, that gap there is 10 squares and it's 40 pounds. 10 tiny squares. So if I'm back 2 tiny squares, I'm back 8 pounds. Okay, this is side notes. So we need 700. 700 is going to be halfway, which is between these 2 lines. There, you actually want the 700, and you'll have to go between 2 lines. Come across to the graph, find where the cross is. That seems to come straight down this last line here, just before the 60. So £60 1 square back is going to give me, 1 square is going to give me £4. So this is going to be £56. So total 3,700. Remember my trick with ratios. When you've got a ratio, you must use multiplication to create new lines, or which is effectively what we've done using the proportional graph. But once you've got those, you can comfortably add columns together. So we've got £288. He also has £100. So total in pounds is 100 plus 288, which is £388. Which devices can he buy? It looks like he can buy a computer, he can buy a camera, but he can't buy a watch. Okay, so he's got a total of 388. So camera or computer. No watch. The watch is way too expensive. These numbers here, you'll probably be given some leeway up to about £10 total, because it wouldn't make too much difference to much of the answers. You'll be allowed up to about £10 by reading the graph incorrectly. Right, travel graphs. Anna drives 45 miles from home. So here's the distance from Anna's home, and yet 45. So they've shown us that part of the journey where she's got to her meeting. Anna's meeting lasts 1 hour, and then she drives home at a steady 30 miles per hour with no stops. Complete the travel graphs to show this information. Well, the first one is if the meeting lasts 1 hour, she's not travelling. Not travel time is a horizontal line for that one, so she had half an hour break going there. So we need an hour's break here, which is from 2.5 to 3.5. So that was the meeting. And then you can do it by calculation. She's got 45 miles. So if we remember, speed is distance over time. We know she's doing 30 miles per hour. She has 45 miles to go. What time is it? Sorry, 45 miles to go. Yeah, what time is it? Sorry. Don't see why you need to know what tools I'm using. So just slide that up. So 45 miles, 1 mile per hour is 1 hour. So what time is it? Problem with these questions is you can flip them. So 1 over 30 is t over 45. And then if you rearrange to get t on its own, you're going to multiply by 45 on both sides. So 45 times 1 over 30, and that gives you 1.5 hours. The second way to approach this one is just to do it using 30 miles per hour with no stops, and know that per hour means 1 hour. So from this point, 1 hour on, so there's the hour, she's gone 30 miles. So back, not to 30, but to 15. And from 3.5 through that, use your ruler, keep the line going in a straight line. So use a ruler tool to go through that point, keep coming, and you should find that she comes home at 5. Slightly low on that end, that's fine. So that's 5 hours. No, at 5 o'clock. That's where your 2 marks come from. Question 3. This is another one using slightly different thing. We're now talking about litres in fuel. And that's how he's doing it. Little question for you to think about. What happened here? Well, that looks like at about 3:30 he's filled his tank up. He's using less fuel per hour here than he is losing here. So he's probably going faster in this section, or he's less efficient. So read at 1 o'clock. What time? How much fuel did he have? Well, 30 to 40. We're halfway. That's 35 litres. That's just part A. At 3:30, Jim stopped, put some petrol in his tank. Oh yeah, we already said that. How many litres did Jim put in? Well, we've gone from 10 up to 40. So end. I'm going to start. He's put in 30 litres extra. Work out the total number of litres used by the car between 1 and 6. So we need to work out how much it dropped in both sections of the graph. So here, it's dropped from 35 to 10. So in the first phase, up to 3 o'clock, he's used up 25 litres. 3:30, he used 25 litres. He filled up. That doesn't do anything to us. We're not trying to find out what the difference is between him starting and ending. We're trying to find out just how much is lost altogether. That's a litre, not 1. So from 3:30 to 6, he's gone from 40 down to 15, which is another 25 litres. So in total, he's used 50 litres. So he's done 2 lots of 25, from 35 down to 10, filled up, and then 45 down to 15. So the car has used 50 litres. Question 4, another weird little one, different things. How much does it cost per mile to deliver the bricks instead of times? It lives 2 miles from Bricks R Us, so it's 2 miles from there. How much will it cost? So this is, first of all, part A, 2 miles from Bricks R Us. So he's coming up and reading across to read that value. These are 5 divisions. So that's 5 divisions is £10. And we've got 3 divisions there. So he's got 3 divisions is £6. £6 plus the 50. So it's going to cost £56 for the cost of the bricks at that point. This array doesn't help here. John needs to have some bricks delivered. He lives 4 miles from Barry's Bricks and 5 miles from Bricks R Us. So which one? Work out the difference between the 2 delivery costs. So 4 miles from Barry's, so 4 miles from Barry's, which is going to be here, that's 50. Uh, 5 miles from Bricks R Us, feeds up there, and it's 60 plus 1.5 a square, so that's 7. So that's £67. There's your first 2 marks, and then the last mark is the difference, which is £17. Again, you'll get given some leeway. Let's just have a look at these and say what leeway they will give you on question 4. 2, 3, 4. See, they're saying 15, but accept anything between 64 and 66, 14 to 16. So I'm a little bit out somewhere. Why am I a little bit out? That's definitely 50. Oh, 64, sorry. Let's count the divisions here. 62, 64, 65. Oh, what am I like? So it's £15. So I would have lost an accuracy mark, at least one. Okay. Now this question, if you've not done the stuff in prisms before, you can go back and have a look at stuff to do with prisms for the first part. The section here, to work out the volume, you need two facts, and I've given them to you. At your level, I would expect this to be given to you, although your exam, when you start doing IGCSE, you will be expected to know the trapezium calculation. So you need to calculate the area of the end section. So the first section, that area there, is 6 meters. And then the other section is, we now have 9 meters left over, 2 meters and 1 meter. And if you look at this piece, there's a short edge there and a long edge there that are parallel. So we actually have a trapezium on its side. So all of that bit is trapezium, and it needs its formula. So the area for section part B, that's the area of part A, the little rectangular shallow end, the deep end and the slope, section B. We need 1/2 the sum of the parallel edges, so that one's 1 and that one's 2, multiplied by the height, which is the distance between them, 9. So the area of that one is 3 times 9, 27.5 of 27. So just put it into the calculator and do the total area from that. So 1 over 2 multiplied by a bracket of 1 plus 2, close the bracket, multiplied by 9. That gives me 13.5 plus the 6 meters from section A, and we've got a total of 19.5. So that's 13.5, and the area total is 19.5. The volume of a prism is going to be area cross section multiplied by its length, which is how many meters cubed? That's times the length, which is 10 meters. So we've got 195 meters cubed. They've told us the conversion. So turn that into liters. We multiply by 1,000. So 195 meters cubed times the conversion fraction, 1 meter cubed. So the cubes disappear, is 1,000 liters. So that gives me 195,000. 25 litres per minute. So we need to convert that one into minutes. So that volume is 195,000 litres. I want to get rid of the litres to give me minutes. So we're going to divide by 50 litres per minute. That will tell me how many minutes. I want to convert the minutes into hours. So minutes on the bottom, hours on the top. 1 hour is 60 minutes. So to convert that into hours, first of all I take my previous answer and multiply it by 10 by 1,000 to get us up to here. Then how many minutes does it run for? Divide by 50. 3,900 minutes. Divide by 60 to tell us the number of hours. It says it's going to take 65 hours. Let's just whack down to the end and see if that's what it says. 65 hours, there we go. So you get this is a 5-mark question, so you get marks for 1 mark for splitting this up, calculating the areas, calculating the volume, 1 mark for calculating the total volume and converting it. Now here are the 4 graphs. We need to think how this, write down the letter of the graph that best shows the depth of the water in the pool above the line MN. Yeah. So the depth, we've got to think about the cross section and what it does. So what happens, describe the phases. As it fills up, it fills quickly. That's when it's at the bottom. Partway through, because this is wider, the volume it goes up by is going to slow to fills less quickly. At 3, we've got 2 values. It should be fairly slow. Doubly less quick. So fills quickly is looking at a steep graph. Which graph starts quicker and then fills off? It's not that one. It's not that one. Gradually fills up less quickly. That's filling up less quickly. That's filling up less quickly. And it's this last part which leads to the final part. In this last region, it's filling up at the same rate. Section 4, constant rate. This one doesn't show a constant rate. This shows it continuing to fall off, and that will be the case if it's sloped, continued sloping. This one shows a change about here where it floats up. So the answer we need is C. So you've got section 1, 2, 3, and 4. And that's why that one works. So put my answer C into the box. Question 6, trial and improvement. Now I'll show you my trick on doing the calculation as well on the way. We know the solution lies between 3 and 4. And because this has got a positive high term, I did tell you the little trick that 3 and 4, we need the calculation x cubed minus 5x, and we need the statement it leads to. It says give the answer to 1 decimal place. So because of the nature of this, we know this is going to be small. 3 is on the small side of x, 4 is on the large side. We know it's between those 2 values for x. We don't have to do the calculations. Sensible thing, try 4.5. Now these numbers that you're trying, the ones I put in brackets, you may choose to use slightly different numbers, but there are certain numbers that must be seen. So let's do 4.5, store that into my value for x, and the reason for that is I can get it to calculate this value. Rather than typing 4.5 in for each x in here, I just need to use the x term. So I can do x alpha x cubed, which is shift cubed, or use the hat and put a 3 after it, minus 5x, and it tells me 4.5 is 68.6. 68.6 ... That means it's too big. So 4.5 is on the big side of my number. Choose another one. Let's try 4.2. Store it into the x. Press equals. And now, with a decent calculator, you should be able to go back up. Find the calculation you were doing. If you press equals, it will recalculate it. So, what x value do I put in? 4.2. And that's saying 53. That's saying getting rid of this 4.5 again. So try another number, 4.1. Your kid had told me I'm trying numbers which are all too big. It's between 3 and 4 I should be doing. So yeah, kid had told me. Let's remove all of that. My numbers were getting too big. So put the pencil in. Let's try 3.5. These numbers, this number, I would expect to see it really. This number I would expect to see. The first decimal place, always try 0.5. So I need to do 3.5. Store into my value of x. Shift, store in x. And then do my calculation of alpha x cubed minus 5x. It'll give me an answer. That's 25.375. I don't need to know the answer to too many decimal places, but at least more than one. This is small, so we know 3.5. It's on the small side of my value. Some people say too big, too small. I just like to be able to see everything in the last line. Try another number. So these numbers, whichever ones you try, are up to you. But you must, I'm going to leave that out for a minute, but you must have numbers which go either side. So let's try 3.7. And one feature with these calculators with the fancy memories is if I type 3.7 in, shift, store, and put into x, didn't do store, store to x, store it, press equals, and then go back to find my calculation and press equals, and I get 32.1 dot 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 dot. This is too small again. 7 is too small. 3.8, let's try it. Because we're quite close now. I think 3.8 might be too big. 3.8. Shift, store, into x. Go back up and retry the calculation. And this is now 35.8. So I know it's between 3.7 and 3.8, and I've got to decide which one. The way to decide which one, so that definitely would have to be seen, that would have to be seen. The two numbers either side, the one that is just too big and one too small, those two numbers must be seen. So now to choose, you go halfway between them. And it is halfway. Do not try any other value there because it can be misleading. Things like cubic crafts and things where if you think, oh, it's only halfway, I'll try it. You're not looking for more accuracy, you're just trying to make a choice between 3.7, 3.8. Easiest way, go halfway. So type in shift 3.75, store that into x. Go back up, do the calculation again, and this now says 33.998, 33.98. Now that's probably the best solution we've got, but it only wants one decimal place. So 3.75, this is too small, so 3.75 is on the small side of x. So that means we need to round it up to the 3.8. If you actually put these in correctly, comparing to the 34, it will get rid of the wrong side. So we get the final answer 3.8 to 1 decimal place. If you put in 3.75, expect to lose a mark. People who have Casio calculators, if I can find mine. You can see I've done questions like this before, so we'll just go back to standard calculator mode, it's mode comp. There's a cheat that you can do to help you choose these numbers quite quickly. If you go into mode, table, and type in your equation, so I've got alpha x cubed minus 5 alpha x. Start at the lower value we know, end at the top value we know, and what we want to do is we want to go up in 1 decimal places, 0.1s. So we say step in 0.1, press equals, and we get a list of numbers. We come down until we find the pair either side of 34, which is those two, 37, 3.7 and 3.8. So these lines would need to be seen, and then you can do the division between those. Right. Now this is the weird part. Cancel, the equation stays the same. Start at 3.7, end at 3.8, and then half this number, so it's 0.05. Remember, the next decimal place, half the 5. When you look at those, you've got your three numbers. 34 is between 3.75 and 3.8. So your 34 is in here, so your answer's between them. We only want the 1 decimal place version, so you either round the 3.75 up, or it's got rid of the bad one, so 3.8 anyway. That's the different techniques for using calculators to solve that problem. And I'm fairly certain that's the end. Let's just show you the mark scheme for the last question. Now, for a trial, 3.7 to 3.8 evaluated, 2 marks, 1 mark for each of them. And there's 1 mark here, 1 mark here. You get 1 mark for the testing between these, but it's not needed. Doing the differential trial, finding that one, is 1 mark. And then depending on you doing the previous step correctly, 3.8. Okay, so no working scores, no marks given if the answer is correct. So you must show these values. These are the critical ones, that one, and that one. They must be seen. I would always recommend showing that one as well, but it's not absolutely necessary.